pay more attention to what I want to explain right now. You know, there have been a kind of confusion in statistic and machine learning world. Okay, but I'm going to say um, today I actually want to bridge a gap, okay, between the use of the two methodologies. The fact remain, um, when you talk about statistical models, machine learning algorithm, I'm actually going to say um, the two of them are part of they are another form of statistics, you know. But let me first say this. We got difference between model explanation and model prediction. You know, in a research world, okay, in a research world, we need to be able, for us to be able to know which one to use between model explanation and model prediction, we need to first of all decide, do we want to predict or we want to explain? There's a difference between the two. I'm going to say that again. Do we want to explain or we want to predict? Okay. Now, let me tell you this. When you want to explain, okay, we use model explanation. That is more or less what we did in statistical world. We do a lot of model explanation. We, you know, economists, psychologists, sociologists, in scientific community in general, what we actually pursue an explanatory goal. What do I mean by explanatory goal? Explanatory goal means we want to understand the world and we want to explain the world. Okay? Before you can explain the world, you need to first understand the world. And that is synonymous with basic science, because basic science has to do with understanding reality and, explain reality. And if I'm pursuing an explanatory goal, okay, I'm actually going to use model explanation. Statistical models are good for model explanation. You know why? Is model explanation. The model explanation, because of the fact that, when you look at the response variable that we call the dependent variable, we normally believe there is 100% variation around it. And what we normally do is to isolate the contribution of other variation to that. Okay. So when you pursue an explanatory goal, it means you just want to explain. And let me tell you, when you say you want to explain, explanation means I want to know the effects. I want to isolate effects of some factors, okay, on a particular response. I'm going to give you an example now. I want to talk about classification. I actually want to look at the effect of maybe numbers of friends, my age, exercise that I do, and some other factors on, on my happiness. It's either I'm happy or not, right? Got two levels, right? Which is binary, right? Okay. Now, if I'm pursuing an explanatory goal, okay, I think I'm going to start writing something on the board. Okay. Now, this is serious. We got one, explanatory goal. We got predictive goal. Okay. Now, explanatory goal, it means you just want to explain. Okay. Then I need model explanation. Okay. And that is what we do in statistics in general. Okay. We talk about model explanation. Okay. Now, do you know that when I'm looking at the effect of numbers of friends that I got, the numbers of exercise, amount of exercise, and so on happiness, right? If I want to explain, I'm going to use statistical logistic regression model. The statistical logistic regression model will actually enable me. I think I'm going to let me do this. I'm actually, I don't know this guy, and I'm going to stop this. Okay. Now, what I'm trying to talk about is this. You know, when I'm pursuing an explanatory goal, then I need to specify my model. When I specify my model, okay, parameter estimation will be involved. I will actually estimate maybe the regression, the coefficient associated with the risk factors. Then I will test hypothesis about it. It's going to display a p-value. Then I'm actually need to take into consideration assumptions. When you are pursuing explanatory goal, we got a lot of assumptions. Like for instance, what I'm trying to say now, statistical logistic regression has assumptions. Okay. Now, assumption number one is multicollinearity. Okay. In case you have so many variables, multicollinearity, we actually need to investigate that. Then another assumption is that the log of odd ratio, okay, the log of odd ratio, okay, that very log that we also write as maybe p over 1 minus p is linearly related to the independent variables, which make a statistical logistic regression to be a linear model. It's a linear model. Does that make sense now? So I'm only going to use the statistical logistic regression model if my intention is just to look at effects. I want to explain. When you are explaining, you are looking at the effect of variable on a particular on response. You are not interested in prediction. Okay, you are just explaining. Then with that, we'll be able to talk about causality. You want to talk about causality, okay? You want to be able to retrace a particular outcome, okay, a particular effect to a particular cause. Does that make sense? That is what we actually use statistical logistic regression model. Okay, now what is going to be the metrics of evaluation? How do I know my statistical logistic regression model is going to do a great job? Then I need to look, I can look at the adjusted R squared. I can look at the AIC, okay, and so on like that. So the metrics of evaluation for statistical logistic regression model is different from metric of evaluation for machine learning logistic regression model. Is there anyone who asked, do you have a question about statistical logistic regression model before I move into machine learning logistic regression model? Is there any question? Okay, so the bottom line here is for for statistical logistic regression model, okay, parameter estimation will be involved, testing of hypothesis will be involved, checking for assumptions will be involved. You know, the metrics of evaluation, don't forget, is going to be, you have to consider module selection criteria that put into consideration module fitness and module complexity. Now, I want to come to I want to go from explanatory goal now to predictive goal. Let me tell you, in 1948, once a scientist argued that explanatory goal and predictive goal have the same uncertainty, but in 1959, it was discovered that uncertainty around explanatory model is different from predictive model. And explanatory goal does not translate to predictive goal. Now, I want to talk about, I want to pursue a predictive goal now. I'm not interested in the effects anymore of factors. You know what I'm looking for? I'm actually looking for the best combination of variables that will give me the best prediction. I don't care about multiple linearity. I don't care about assumptions because machine learning algorithm work with big data. So I'm not interested with all those assumptions. But the problem with the machine learning algorithm is that it's actually going to have interpretation issue. Why statistical logistic regression model will be more interpretable. Okay, now if I'm pursuing a predictive goal, I'm actually going to use machine learning logistic regression model. I don't care about assumption, okay? But there's something I care about. And there's something I'm going to do that I did not do in statistical logistic regression model that will enable me to address assumptions of multicollinearity, which I'm going to tell you now. When you are using statistical logistic regression model, okay, you don't do data splitting. You are about data splitting, right? Data splitting. We don't need it in statistical logistic regression model. Do you know why you don't need it? You don't need it because don't forget what central limit theorem tells us. We need a lot of data. We need to work with large sample. Okay, so a model explanation, okay, situation where you are pursuing explanatory goal, you don't split your data. But when you are pursuing a predictive goal, then we need to split your data. Now you're going to split your data into training and test. And I want to reframe the question now. I want to predict the probability of whether I'm going to be happy or not. I don't care about effects of, effect of a particular variable that make me happy. I'm not interested. Then I'm actually going to be pursuing a predictive goal. Now, predictive goal, it means I'm actually going to be using logistic regression within machine learning framework. Then I'm going to split my data into two. Okay. Then I'm actually going to, figure out my model from the training. Then I'm going to test the performance of the model with a test data. Okay. Now, let me tell you how this work. Okay. There's going to, we're actually going to use something that we call cross validation. Cross validation. We don't use cross validation in statistical logistic regression. I told you the metrics of evaluation in statistical logistic regression. We base it on p-values, see how significant the independent variable is, talk about the adequacy of the model, assumptions, and so on like that. That is what we care about. But in the machine learning, if I want to talk about the metrics of evaluation, I'm going to talk about cross validation, where I'm actually going to split. I'm going to generate subset of data. Okay, when I generate subset of data, I'm actually going to have it in in k fold. Okay, and I'm actually going to do k minus 1. Okay, so that k fold there will be equally sized. Okay, I'm actually the k minus 1 I'm going to train with the k minus 1. Then the remaining one I'm going to test the performance. Okay, the metrics of evaluation that we use here is accuracy, precision. You use accuracy, precision, recall. Okay, RAC under a curve. Okay, these are the metrics of evaluations when we talk about logistic regression within machine learning framework. And let me tell you this. if you take it, if let's say for instance you are comparing, you are bringing in random forest, okay? If you are bringing in random forest, you can only compare random forest with logistic regression under machine learning framework. It doesn't make sense comparing random forest with statistical logistic regression. I don't know if I'm making point. It doesn't make sense because the random forest, okay? Let me now tell you this. The random forest can also be used for classification problem, okay? In the sense that it is more complex model compared to logistic. Logistic assume a linear, and at times the relationship could be non-linear, and the random forest make use of assembled trees. There's so many decision trees, and each decision trees can actually fit the data, and at the end of the day, the whole thing will be average, which means the statistical idea is used in machine learning algorithm. So if you now want to compare, you can compare accuracy with machine learning logistic regression with accuracy in random forest. There's nothing like using statistical model, we don't talk about accuracy. We don't talk about accuracy. Okay, we talk about precision. That's what we talk about. So now, let me tell you this. You've now seen the difference, but there's something I'm going to emphasize more. That I really want to talk about. That we got tensions. We got tensions between explaining and predicting. Tensions. Okay, between explaining and predicting. Let me tell you this. If your model is doing a job of model explanation, then it's not going to have more predictive power compared to machine learning algorithm. Machine learning algorithm does not have more explanatory power compared to statistical model. I'm not saying one is better than the other, but the want to use depends on your intention. Do you want to explain or you want to predict? But what I want to talk about now is just to make a difference, to make a distinction between explaining and predicting. Number one tension is theory and data. I'm actually going to say theory versus data. And I'm going to explain it. This is number one tension. Statistical model emphasize more on theory. In scientific community, emphasis is more on theory. Okay, we only complement our theory with data. We're using data as spies. And that's what we do in scientific community. Statistician, economists, psychologists, sociologists, emphasis is more on theory. Does that make sense? But if you want to talk about machine learning algorithm, now the emphasis is more on data. Why theory is used in a less formal way? Look at the difference between the two. When you are explaining, which means you are using model explanation, emphasis is on theory. And that is why we care about assumptions. When you specify a model, because your model is always going to have a stochastic part, the random part, and assumptions will revolve around the error, and what makes your model to be good is when all assumptions hold. So the emphasis is more on theory. Okay, why we use data as supplement, but when you are predicting, we're actually going to use theory in a less formal way. We focus more on data. So that's why the machine learning world, we care about quantity of data. It has to be so many. That's why I call big data. Does that make sense? Now, another tension that I want to talk about, okay, correlation versus causation. Correlation does not imply causation. Does that make sense? If I look at the relationship between ice cream sales and crime rate, maybe maybe I observe the relationship is positive. Does that mean ice cream sales will lead to more criminality? No. And we got so many reasons why we cannot conclude causation on causation. And number one reason why we cannot conclude causation, there could be some confounding. Maybe the reason why there is more on sales of ice cream is because of the weather. Maybe we're in summer. Does that make sense? So, and that is the reason why, if I really want to conclude on causation, this is the reason why in the scientific community, we care more about conducting experiments. When we conduct experiment, that will enable us to use the principle of randomization, where our confounding effect will be eliminated. Okay. Number three, retrospective, okay, versus prospective. Let me tell you this. When you are pursuing an explanatory goal, then we're looking backward because we want to explain reality. How did it happen? Then we look backward. Okay? Looking backward is like we're going retrospective. That's what we do in scientific world. Okay? It's looking backward. But for prediction, it's forward looking. Prediction is forward looking. You see the difference now? One looks backward, use historical data. Okay? The other one is forward looking. Number four, okay, individual versus average. Oh my God. Whenever you are pursuing an explanatory goal, we focus more on a group level. If I want to look at the effect of this, okay, I look at it, I'm talking about average effect. Does that make sense? So we care about average more, okay, in when the goal is explanation. But when it comes to prediction, we don't predict at group level, we predict at individual level. Does that make sense? Prediction is made on individual level. But do you know I'm looking towards the future? Okay. Can we also make a prediction based on average level, based on group level, and explain based on individual level? Okay, I'm trying to look at how explanatory goal, what we should be looking for in scientific world right now, whether those who use statistical models or those who use machine learning algorithm, we should look at a way how explanatory goal can translate into predictive goal. Okay, and number five, this is very important. Bias versus variance. Bias versus variance. Let me tell you this. The worst enemy, okay, of every statistician, every economist, every psychologist, everyone in the scientific community is bias. Bias is a simplified assumptions made, okay, for you to be able to estimate your target function. When what we don't want, even though we can't prevent bias, but we don't want high bias. You know what they call high bias? Okay. What we mean by I bias is when you use a very simple model for complicated reality. What is going to happen? When you use a simpler model to model complicated reality, your model will not detect the signal. Your model will not dictate this or the pattern. Your model will not dictate the relationship. What is the consequence of that? Your model will underfit. And what we normally do is, how can we solve the problem of I bias? We can decide to add so many variables into the model. But when you do that, you're going to solve the problem of I bias, but you're going to run into another problem that we call I variance. Do you know that one of the disadvantage of random forest is I variance, right? But it has a way to control that. Because we actually, it has assembled trees. Each tree is actually going to fit the data, and you're going to a particular tree will have some prediction. Then you do average prediction. If you want to figure out the estimate of the overall performance, with that, it will be able to control that. So I variance I actually occur when you use more complicated model for simple reality. You know what's going to happen? Your model will perform great with training data, but will perform poorly with unseen data. So which means you may not be able to generalize. And what are we trying to do? We are trying to minimize whether you are pursuing an explanatory goal or you are pursuing a predictive goal. We all need to strike a balance between bias and variance. Okay, how can we secure low variance and low bias? Because low variance and low bias, we actually attain accurate prediction. And this is what is common, when it comes to, I need you to take a look at this. There's something that we call expected prediction error. Which is it? Okay, now take a look at this. It can be broken down into that. This guy, it doesn't change whether you are doing model explanation or you're doing model prediction, is the same. But these two guys are the bias and the variance that I talk about, that you need to control, that you need to strike a balance. How are you going to find yourself in the middle? Like having low bias and low variance. And that is up to us. Is there any question on this? Is there any question? So what I'm going to be expecting in your project, for those of you, if you use logistic regression and random forest, don't compare incomparables. It means you are using logistic regression within the machine learning world, where you're going to use a cross validation, where you're actually going to use the same metrics of evaluation and you to compare them. Does that make sense? And if your intention is maybe you are pursuing an explanatory goal, you really want to see what is the contribution of a particular factor to the response, then you got to seek redress using statistical logistic regression, where the p-value is going to help you out. Then where you're going to use model selection, the model selection criteria that put into consideration model fitness and model complexity, talk about adjusted R square, talk about AIC, and so like that. Is there any question before I go? Is there any question? Okay, so I'm going to be expecting your name and the name of the person that you swap your document with. And before the end of this week, I'm going to release a kind of instruction or direction about how the presentation workshop is going to be. But like I said, we are not going to have it in person. We're actually going to have it on Zoom, where individual is going to make a presentation. So what I'm going to do, because everybody cannot present, okay, in one class. So what I'm actually going to do is I'm going to put you into a group. Okay, those who will present in a particular day, those who will present in another day, you're only going to make presentation for just 5 minutes before we allow question time. Okay, make sure you also say have a lovely day. Bye for now, everyone.